Okay, we're finally going to use inverse trig functions and the unit circle to find all the solutions to a simple trig equation. For this example, I did change the negative 0.5 to 0.5. The picture is a little easier to see and it's not much different. So how does this go, right? We wanted a y value of 0.5. When we used the inverse trig, we got this. And we ignored this point because it was further away. But now we don't want to ignore this point. And so what's going to happen is we need to figure out what the relationship is between the value the inverse trig function gave us and this one. Now this is really kind of cool, and we're just going to use the circle to do this. Notice, by the way, that this distance right here is exactly the same as this distance here. Now how can I use that? This is what I'm going to do. If I want to get to this point without any thinking, right, I'm going to go too far. Well, that's all the way to pi. And then I have to go backwards the same distance here I went forwards. I'm going to go 0.523598775 7756. That says if I go 0.52359877756, roughly, I'm going to get a y value of 0.5. It also says if I go all the way to pi and then come back that distance, I'm also going to get to the other point whose y value is 0.5. But there's an infinite number of solutions, and this goes exactly the same way cosine did now, right? If I hit this point and then do any number of whole laps, I'm going to end up at that point where the y-coordinate is 0.5. And the way we usually write that is something like any number of whole laps. In fact, as we should say any whole number of whole laps. All right, over here, I can go to this point and now do any number of whole laps. We usually try not to use the same number there. I used n for cosine. We can use n here. It's very, very important that you rely on the circle here. There are going to be so many times in math or physics or any place that where a circle is used where we want to rely on the circle's picture to actually give us the relationships between the points. Otherwise, we're memorizing stuff. And it's really hard. I don't want it to be really hard. So that's it. If I have one good point for sine, I can get the other point just by going too far and then backing off a little bit. That's it for finding all the equations of a sine equation using one that we got from an inverse trig function.